Stay put for world-ending coronal mass ejections, real video of the sun's surface with sound, and incredible images of our sun as you've never seen it before. At the center of our solar system is the one thing that has made life on our world possible: the sun. A blazing ball of plasma radiating heat and light, with structures as large as the state of Texas, propelled by convection currents around its surface, and a mass so large it keeps every object in our solar system spinning around. In today's video, we're going to explore the mysteries of the biggest object in our nearby space and show you the sun as you've never seen it before. We all know that the sun is the most important part of our solar system. Not only do all of the planets orbit it, without the sun, we would not have the light or warmth to sustain life on planet Earth. But while the sun is a good thing for us on Earth, getting much closer would be a pretty bad idea. That's because the sun is in fact a giant sphere of superheated ionized gases. As far as composition goes, the sun is made up of 70% hydrogen, 28% helium, and then a variety of carbon, oxygen, and nitrogen to make up a further 1.5%. Some smaller elements like neon, iron, silicon, magnesium, and sulfur make up the remaining 0.5%. As time passes and the sun continues to burn, those percentages will slowly change. The reason the sun is shining at all is because of the nuclear fusion reaction powering its extremely hot core. This occurs due to how much mass the sun holds. At its core, the force of gravity is so strong that hydrogen atoms are squeezed together until eventually they merge. 4 hydrogen atoms merged together will create 1 helium atom, with some of the hydrogen atom's mass being converted to heat and light as a result. From planet Earth, the sun looks like a rather stable celestial body, but closer inspection reveals that the roiling plasma that makes up the sun is anything but. Solar flares occasionally rip out of the surface of the sun, shooting particles out into space in what is known as coronal mass ejection. These solar flares are thought to be caused by something known as magnetic reconnection. They are a sudden explosion of energy caused by the tangling or crossing of magnetic field lines. Solar flares aren't always strong enough to create a mass coronal ejection of plasma and sometimes just manifest as an area of increased luminescence. But when plasma is kicked out of our star, it can be a breathtaking phenomenon, with the largest flares having the potential to knock out all electronics on Earth. For the most part, these huge solar flares miss Earth, but if one were to hit, it would have catastrophic consequences. But this sort of activity isn't happening all the time. The sun goes through its own solar cycle. Every 11 years, the sun's north and south poles trade places, a cycle which has been observed for centuries by changes in the appearance of the sun itself, as well as phenomena like aurora here on Earth. Over the course of this 11-year cycle, activity on the sun can be observed in a state of synchronized fluctuation. Solar flares, coronal mass ejections, sunspots, coronal loops, and even the level of solar radiation are all tied to these 11-year cycles. The peaks and dips in this cycle are called the solar maxima and solar minima. At the maximum point, sunspot activity will be at its height, and solar flares shooting billion-ton clouds of ionized gas into space are common. On Earth, this means we will see many more aurora as the ejected particles from the sun collide with our atmosphere in a dazzling display. Space agencies, however, have to be on high alert. Radiation storms hurled out by the sun across the wilds of space may be beautiful from the ground, but they can be dangerous to astronauts in orbit. Satellites and other communication systems can also be damaged in this time of solar maxima by rogue storms of solar radiation. Minima are the exact opposite. Sunspot and solar flare activity is almost non-existent. Sometimes days and weeks can go by without any form of major solar activity. Observing the sun from Earth and from satellites in orbit has taught us much about how the sun operates. As you are looking at these images, you may be confused as to why there are so many different colors. If you were to take a photo of the sun with a standard camera, you would get to see a familiar yellow-colored orb. The sun exhibits this color in photography because yellow is the brightest wavelength from the sun, so that is what our eye and basic cameras pick up on. Not that you should be looking at the sun with your eyes directly. The truth of the matter is that the sun emits light in all colors, right across the spectrum. Scientists take images of the sun with specialized instruments both from the ground and from orbit. Some of these instruments go deep into the ultraviolet range of the light spectrum. This is better for looking at phenomena like solar flares, which are mainly unobservable through the naked eye. The Daniel K. Inouye Solar Telescope, based in Hawaii, observes the other end of the spectrum from visible to near infrared. The image you are looking at, taken by this telescope, is the highest resolution image ever taken of the sun. Each of these cell-like structures are around the size of Texas. They are hot, excited, convecting masses of plasma. Let's zoom in to get a clearer view, and for the full effect, we have added the sound of the sun, which was created by observing the vibrations from the sun over 40 days and transformed into audible sound. The sun is both a provider, yet also a destroyer. Venus, the second planet from the sun, is the hottest in our solar system. Heat from the sun is exaggerated by its thick atmosphere and high pressures on the surface. But did you know that we have actually landed on Venus and taken images of the surface? Click here to find out what the Russian probes found when they touched down on Venus. Thanks for watching Elder Fox. Remember to subscribe and hit the bell so you don't miss out on the latest discoveries.